Hello, I'm Philip Stoten. I'm here in Las Vegas at CES 2015. I'm on the booth of Cambridge Consultants and I'm joined by Ruth. Ruth, thanks for talking to me. My issue with wearables here is there's a lot of stuff that isn't really a wearable. It's just a piece of electronics technology with a strap or hung around your neck. This is a real wearable. Tell me about the technology and tell me about the challenges it overcomes.
So we were facing that similar challenge. I mean, we do a huge amount of connected system development for our clients, a lot for performance monitoring or technique training, and a lot of that is MEMS-based technologies. But that's great up to a certain point, and it's good for certain applications. But it is just electronics on different parts of your body, kind of electronics bolted on. We were really trying to think about how can you make a wearable that is truly wearable and actually make the garment itself inherently smart. So this is using a fibre optic based technologies. This is not using MEMS based sensors at all. So what we've got is a single optical fibre, and how it works is it's looking at it can detect the bend. So we can see this on the screen here. It's picking up the movement of my wrist, and also it can pick up my elbow as well. So it's working on a backscattering technique. So the electronics at the moment is below here, and it's sending a pulse of light up the fibre, along the fibre, and then it can pick up. So obviously, when I bend, the light is being reflected and scattered in a different way, and it can pick up that change.
Okay.
So we're just showing a simple concept here using two sensors. Yeah. But we can imagine scaling it. We think we can get up to 10 sensors along a single optical fibre with a single pod of electronics. Okay. So imagine if it could go all over the body.
Yeah. And what kind of applications are you looking at for this? Are you developing the applications internally within Cambridge Consultants, or will you be partnering with other companies?
So we've got it to the stage where we started thinking about the types of things it could be used for. I think it'd be really interesting for technique training in sport. So it's basically used for anything where you're interested in the posture and changes in the angles of joints. So imagine picking up a tennis serve, or golf swing, or skiing if you're looking at maybe your hip, the changes in your hips. Also think about wellness applications like yoga, maybe position, rehabilitation, or in the medical area. Think like gaming, maybe interaction with that, or maybe a low-cost motion capture system for the movie industry. But how we've developed it as a platform, and we're talking to lots of different people at the show, and we've had a lot of interest over the last few days, and talking to them about how we can develop it further with them for their application. So we won't take it further ourselves, but we're looking for people who want to work with us to develop it for their application.
Okay, and for people who don't know Cambridge Consultants, just tell me a bit about the company and how that operates.
So we're an engineering company that does product development and technology creation for our clients on a fee-for-service basis. So it's about 450 of us, engineers, designers, scientists across a whole range of different technical disciplines. So people who've worked on this would be optical physicists as well as the algorithm experts who are interpreting the signal.
Okay, and was this done for a client, or this was done as a kind of a blue sky project?
This was done as a blue sky project. Similar to you, we'd got frustrated on the fact that wearables weren't truly wearable, and we were trying to look at what we could do. Actually, this was a technology transfer from the oil and gas sector, so we developed this in a system for monitoring the change in dimensions of a pipe by looking at the light scattering in the fibre around a pipe, and that obviously was a very high spec instrument that was hundreds of thousands of dollars. We thought, well, how can you actually take that principle and transfer it into a consumer product that is really low cost?
Okay, so you make it into a consumer product, and then you've got two different consumer supply chains that are merging. You've got the apparel supply chain, which is very different to the electronic supply chain, the kind of people that would be involved in fibre optics. Do you look at those challenges, or are you very much, this is the technology and you hand it off?
Well, the types of people we're really interested in working for this, I think people who've got sporting goods brands, for example, who they would have the apparel knowledge in-house. And I think that's what we haven't got at CC, is understanding of the textiles and how to integrate it. So we're really interested in working with sporting goods brands who would be able to do that. And so many of them now have got digital sports divisions within their companies. So I think we could find a partnership that would be really beneficial on both sides.
Yeah, and that challenge is certainly one that's being felt elsewhere, just in this hall. So lots of challenges being met there. Ruth, thanks for your time. Thanks for talking to me. A really interesting product. Thank you.
Thank you.